Okay, so where we left off, we were debugging this very mysterious problem that looks a lot like a bug with Pico 8, but I'm not sure. So here's what we're going to do. Let's reset it. In fact, let's do even better than that. Let's close it and reopen it and see if that happens again. By the way, sorry for the noise. I'm running the dishwasher. No, I want to do exactly the same test case. Okay, so it is repeatable. DFS at 3.3. So somehow, do I just not understand like how the loops work in here? DFS at 3.3. Let's just like scatter these throughout. And let's just put like a 2 in front of it so I can tell the difference. Wait, how come this is needs another layer of indent? Oh yeah, okay, I see. Oh, I guess that's actually the third one. Dude, my dishwasher is making a sick beat right now. I don't know if you can hear it. Let's put one here, too, for good measure. Whoops. Ah. Okay. All right, let's try that, see what happens. Man, I really need a way to like replay stuff so that I can remake these test cases without having to do it manually. Man, it still happens? Where's the DFS at 3.3? DFS at 3.3. What? By the time we get to the bottom of the loop, we get into nothing to see here. Wait, how come we have 2 4s? I think I may have goofed up my log statements. No, there's only one. How come this is running twice? So this is checking the type of the neighbor, this if loop here. I know. So if the neighbor has not been seen, then we check the type of the neighbor. Oh, interesting. I think, for reasons yet unknown, because my end list somehow starts pointing to a different table, don't ask me who's doing that, but because that happens, I think end list gets garbage collected because no one's using it? Nah, that can't be right. Okay, let's try something. I got distracted by my dishwasher's sick beat. I should put a 1 in front of that. Where's DFS at 3.3? Here. Oh, it's still true at 4. Oh, wait a minute. DFS returning? Is that why I've been confused this whole time? Oh. Okay, so I was wrong. It's because the recursive call with just the one neighbor ended. Okay, so there's no like GT bug or anything, which is what I expected. All right. So now we need to figure out why our post condition is getting zorked. Junction 1.right leads to an unlisted net. Let's see if we can simplify it at all. What if I just do this? It seems related to having both nets connected together. There's gotta be oops, I didn't mean to do that. Ah. Ah. Okay. Oh my goodness. I really need a replay system. Let's not do that right now, or ever, because I would only need it for like replaying bugs. On the other hand, if it was built in and someone observed a bug, they could send it to me, which would be cool. So for some reason, all right, let's check out the net dump. Right now, we've only got one net, which is not correct in the first place. We really should have two nets. I don't even know how that works with the other one. It's something that I like fixed by accident on the other one. So this is only one net. This actually makes sense that there's only one net. When I do this and that and that and that, now there's two nets. Don't ask me how exactly. Oh. Same thing. So, okay. I think I'm starting to understand the problem a bit better now. The problem is when we have both nets of a junction that are being the same. Now, in some cases, we do actually split it into two nets through some subtle chain of events through the DFS. All right, let's think about this for a second. So we have something like this. And what happens if I erase this? Well, I expect to have just one net left still, and that is the case. When I erase this, I still expect to have just one net, and that is the case. When I erase this, I expect to have just one net. When I erase this, I expect to have just one net. When I erase this, I expect to have just one, but when I erase this, I expect to get two. Why don't I get two? So if I erase this, it checks all the neighbors, does that, does that, does that. It finds this as a neighbor, reads through the junction, and ends there, and makes a new net out of that. I think what happens is when we reach down, we find a neighbor, which should be a junction. It's supposed to make a new net there, and it doesn't. So let's quickly browse the code and see if we can figure out how. Erase square, where's that found neighbor? Found net neighbor. What's going on here? Found component. Oh wait, do I not have a case for a junction neighbor? Oh no, I do. Found junction neighbor. Oh man. What is the reasoning? If neighbor is a junction, decay it to the underlying net. Oh, interesting. Now it so happens that it's equal to the current net. If neighbor port pinum net equals C, then decaying pointer. Okay, we do expect to see that. Before all the DFSing anyway. Oh, I should have put a separator in the log actually. Okay. Okay, now let's put in some separators and erase that. Oh, I think my log isn't long enough. This is a good chance to test that thing I was doing earlier. Log size equals, I don't know, 200 or whatever, I don't care. Oh, well, whatever, 2. Okay, now put in some separators, erase that, and check the log. Erase square, did not delete last chord of net, found junction neighbor, port 4 on neighbor, decaying pointer. And then it ends there. Oh no, it doesn't end there. We decay to the pointer. And then found net neighbor. Yeah, that makes sense. DFS at 260. Testing neighbor 1. Okay, let's get rid of these end list because now I know that isn't a problem. And it's making it hard to read. Just get out of here. Get out of here. Okay, let's do that all again. Put in our separators, hit that. Erase squares, not erase last chord of net, found junction neighbor, port 4 on neighbor, decaying pointer, found net neighbor, DFS at 3.3. Why are we testing neighbor 1? We should be testing neighbor 2. Oh, it's testing all of them because we decayed it. Oh my god. I think it'll solve our problem if we properly do the neighbor list. And that neighbor list is such a hack. Well, it isn't. I mean, whenever you do DFS, you need some way to know what the neighbors are. The only reason it's a hack is because when I call DFS, I don't tell it what direction we came from, which means in general I need to tell it like what neighbors are valid as an argument, as opposed to having it figure it out from like the objects. But that's okay. Let's see if we can put in that logic and see if it fixes our problem. Now, over in DFS, we do set up the end list. What did I call that? Next end list? Oh, there we go. And now let's go over here. Okay. Neighbor, and now we also need local think it's just this, and we'll see if this penum is actually correct or not in a second. We'll see it in the log. Found junction neighbor, port blank on neighbor. If the net is equal to C, then decay the pointer and also set up the N list. And then this penum J is just penum. And oh man. What argument is the N list? Scene CPJ N list. I almost feel like the neighbor list should be an earlier argument. Let's do it. Let's do it. Which means that all the calls to DFS need to get updated. I guess we can do that. I don't really want to pass a nil there in case like Lua adjusts the arguments. I don't think it would, but so this should actually be here. And I'll put it back the way it was. I really don't like the long variable names. Okay, that takes care of that. So now in here, we will pass nlist. I mean, that's unlikely to fix everything here. Oh my god, everything broke. Okay, hold on. Let's do this one thing at a time. Let's not pass in... Oh, we need to pass in the scene table. I guess we can do that. Actually, it might just be a problem like that. Oh man, this is terrible. Okay, one thing at a time. Let's not do that. Let's leave that. We do need that. But let's over here just not reorder the arguments for a second. And see. Okay, things are back to being normal again. And actually, most things do still work. Whoa. Neighbors J. Where is neighbors J? Neighbor.jt. Oh, I see. Okay, so things are mostly back to normal. Okay, now, one thing at a time. Let's try reordering the arguments in DFS. So let's take this N list and put it here, like that, which means that in all the calls to DFS, we need to put the end list as the third argument. And actually here, now that I know that this name is not an issue, I would rather keep it like that. And now let's see if things still work. Okay, that seems promising. Okay. Now finally, over here, we just need to pass in end list. So things that used to work still work. Let's try some other things that used to work. Whoops, well, I mean, why not? Okay, that's so far so good. Now let's try our test case. Moment of truth. Man, it is even worse than before. Why? Man, this stupid junction logic has just gotten so out of hand. Okay, put some separators in the logs, hit that, and try and follow what happens. So the post conditions is kind of the same thing, although this time we do have two nets, which is nice. What was that dirty hack about fixing something on the grid? No, I don't think that's an issue. Junction 1 down, unlisted net. Oh man, this is so broken. I think we're on the right track though. Found junction neighbor, port 4 on neighbor, decaying pointer. Yeah, that's fine. DFS returned 1 junctions, 0 gates. That is perfectly fine. Found net neighbor. Testing neighbor 1. Yeah, testing neighbor 129, neighbor 2 is net. DFS at 2, 3, testing neighbor 1 is junction. Testing neighbor, that's not right. Neighbor 1 is junction. Oh, because it doesn't have the same net. It thinks it's disconnected, which is fine. Okay, so let's just that DFS returned 1 junctions. Let's see how that is getting dealt with. Make new net from R. What's R? Oh yeah, the list of coordinates. And return gates junction. So new net, type is net, state is whatever that is. Empty stuff. Add that net to the nets list. Because the nets loop clobbered the junctions, put them back on the grid. all junctions. Now, how come this didn't work? Let me check that post condition logic for a second, just to make sure that it's printing out the right thing. Nets, gates, junctions. Junction grid, ports, neighbor, port, dir. Oh, I think that's right. Points to net, whatever. Junction I, p dot dir, unlisted net. I don't understand how that's possible, because over here, we return 1 junction, 0 gates. We make a new net object, we add it to the list, and eventually we get here. And then dot j of jj equals true. Wait a second. Shouldn't it have the junction's coordinate as part of the coordinates of the net? Is that how it's supposed to work? Like, so if I have a regular just junction with a wire connected to it, 2 nets, yeah, they both have the junction as part of the net. And if I erase that, yeah. But if I do this case that we're trying to fix right now, we have 2 nets. One of them doesn't list the junction. Oh, that's fine, actually, that doesn't list the junction. But this net 1, actually, one thing I should do is this dump nets here. Where is that? Here. I should also put in junctions for j in pairs n dot j and junctions. Put that in as well. Whoa. Oh. Net 1, it's just the junction. And it's almost right. I don't really mind that it like disconnects randomly off one of the ports of the junction. I mean, it would be better if it didn't do that, but it's okay. I think if I just squint at this logic down here long enough, I'll figure it out. For every junction in the list of returned junction ports, nn.j of jj equals true. This appears to be happening. jj.net equals nn. This appears to not be happening. And the grid is fine. Oh, wait a sec. Are we returning the port object or the junction object? That might be the issue here in DFS. I mean, I would find it hard to believe because it's been working pretty well in a lot of other cases. What is it that we add into that J table? Else if grid of L dot type is junction, then for every port in all grid of L dot port do. If P dot net is equal to N, then add CL. Oh, nice. Add JP. Break. I'm not really sure what this break is doing here, but that's okay. I don't really care. Technically speaking, this will hit the same thing twice, but that's okay. I don't really care because of this break. Maybe that's what this break is for, because the port has duplicates. Like this port table has like port 1 and port 3 are the same if it's a flyover, for example. So we are adding the port object, and then here when it gets returned, returned so many junctions, so many gates. Do I still have this case open? Yeah. All right, let's do it again though, because I didn't put in the separators. Okay, separators. Oh shoot, I goofed up. Might be able to make it happen with just this. Separators. Yeah. Now go in here. Delete last chord of net, found junction neighbor, decaying pointer, found net neighbor, DFS, testing, nothing is here, DFS returning. DFS returned 1 junctions, 0 gates. So the net that created now, here's something strange. That other DFS loop should have picked up. Okay, I think I see the real issue here. The other DFS, okay. So actually, where's my separator? Right there. So right here, this one junction 0, I think it's correct up to this point, but then we go here, found net neighbor. Testing neighbor 1, nothing to see here, test neighbor. Neighbor 2 is net. DFS at 2, 3. Neighbor 1 is junction. But then nothing happens. Why? Is junction. Neighbor blank is junction. If O.net is equal to N, then a bunch of stuff. Otherwise, nothing to see here. I know. Just nothing happens. But it should be equal, right? Why isn't it equal? Why isn't it equal? Else log this junction is not connected. I mean, we're definitely going to see that, but why? Put in our separators, hit that. Yeah, why isn't that connected? DFS return 1 junction 0 gates, found net neighbor, blah, blah, blah. DFS at 2, 3. Neighbor 1 is junction. This junction is not connected. Why? How is that possible? What does this initial call to DFS look like? DFS L plus D. Wait, hold on. What are the arguments to DFS? L and what is C? Found net neighbor. I don't understand. How come the DFS doesn't find that? That's the issue here. Why? Found junction neighbor. Yeah, there's no decaying happening here. Why? Why, oh why, oh why? Let me think about this carefully. So right before I erased this, okay, let's check the net dump here. Just one net, which is expected with 2 junctions, with just one net, and everything's fine, right? And as soon as I erase it, I guess we need to follow the log carefully. There's really no other option. So let's put in some separators, hit that, and take a look. Found junction neighbor, port 4 decaying, found net neighbor DFS, nothing to see there, DFS returning, everything's fine. That's okay, good. Found another net neighbor, add that to the coord list, DFS, nothing to see there, turn down, 2, 3. So at this point, in principle, the junction now has 2 different nets. We should only be editing that one port on it. Okay, let's try and add that in there. So for JJ, now we're gonna do log, I don't know, put like a this or something, or that, or this, yeah. Other ports on same junction for key in all jj.parent.port do log net equals C and then to stir p.net equals nn. Okay. Separators, hit that. Wait, what? How come that's fine, but the other one isn't? I think, wait, has this whole time just been because I have like a typo in one of those lookup tables? No, maybe the order is different in the... DFS returned 4 junctions. Well, whatever. I don't really care because up to there everything's fine. DFS returned 1 junctions, 0 gates. We set it, and now we have 2 ports that are equal to the new net and 2 ports that aren't, and yet still this junction is not connected. Separators. Net equals NN true, net equals C false. Net equals NN false, net equals C true. Net equals NN true, net equals C false. So then why does it say that the junction is not connected? It doesn't make sense. Let's go down here. I know So this C, where do I assign to this C? It's just the thing on the grid. So it's a net. Remove it from the list. And we pass it here inside DFS, but I don't think at any point... Oh, because of the decay. No, that only applies to the neighbor. We don't ever assign to C elsewhere in this function, as far as I know. So when we call this DFS, we get that C. And do we always pass the same C when we do recursive calls? All right, we got to do something really like, just like global debug thing. Now here, when we go in here, we'll do global debug thing equals C. And then in here, connected, log, I don't know, o.net equals debug, o.net equals, so I made toStir global debug thing. As in case you can't tell, I'm not planning to keep that. Separators. I wonder if it's just like a bad lookup value for the port number. I should print out the port number. What am I even doing here? If O, so O equals grid. Okay, let's grab this pnumj here. Log pnumj equals pnumj, and we'll also assert pnumj. pnumj equals 3. That's right. Testing neighbor 1, pnumj equals 3. 0, 1. Oh no, 1, 2, 3. Oh, wait a minute. Oh, I think we set the wrong one? I think I find the problem. This first call actually wasn't correct. Do you see here in the like faces there, other ports on same junction? I used a for all, which goes through it in order because it's a list, not like an arbitrary key value map. And port 1 is set to the new net, and port 3 is set to the new net, but that's not correct. It should be ports 2 and 4. So I think we found the problem at last. Go back here, returns 1 junction. So the junction it returned was not correct. So we did put in the n list. The n list was right, but for the return to junction wasn't. So where does it... Okay, I don't need these stars anymore. Just get out of here. Oh, it just picks one arbitrarily. Oh my god. That's the problem. Okay, we finally found the problem. So now how do we fix it? We need to know what neighbor. Like, that's all there is to it. I guess we will just do local dir to penum. I'm just doing this the dumb way, okay? Just don't at me. Equals 1 GW equals 2. There's probably a nicer way to do this. I don't care right now. Equals 3 minus G equals 4. And we don't want to do 4p in blah. We want to do if grid of L dot port assert and list 1 assert length and list equals 1 to penum of n list 1. What the heck? Well, it's progress that this actually did stay connected, but we still have a problem. All right, let's... Whoops. Put in our separators. Port decaying pointer. DFS returned 0 junctions. Well, that's not right. Okay, well, we moved the problem to here. DFS return dir to penum. I think this is probably just not right. Port 2 then. Well, I already know that's not happening. Let's debug penum here. Log. Should be 2. We're almost there. We're almost out of this problem. Penum equals 2. I mean, that is correct. It should be adding that junction. So So how come? Oh, wait. Ah, that's why. .net. Yeah, okay, that should do it. This should fix it for sure. I would stake $50 on it. Oh, well, okay. The problem wasn't in the code I just wrote, so I don't lose my $50. The bet is still on though. Attempt to index field parent. Oh, maybe the problem is in the code. Shoot, I think I lost $50. Well, good thing there was no one live. Wait, hold on. Let me check the YouTube there. Yeah, there's no one watching, so nobody made a bet with me, so I don't lose my $50. Oh yeah, this P doesn't exist anymore. So we'll just do local P equals blah. And we can do this. I think it's the right solution. I don't feel too bad about not giving some random Joe Schmo $50. It's like a typo. It's not a fundamental issue in the method. So now I think this will fix it. There, see? No problem. I'll bet it fixes the other one too. Great, we fixed this stupid bug. All right, let's get rid of these extra log statements. Just get out of here, all of you. Let's get rid of this stupid global debug thing. Get out of here. Everything's fine. Good. All right, let's push this. I also want to see what was ultimately needed to fix this. So, oh yeah, let's get rid of the extra log size. Don't need that right now. So, oh yeah, let's also get rid of the dump nets because we don't need that right now. So what was the issue here? My neighbor's lookup was bass backwards. I reordered the parameters to DFS just to make it easier to pass in a neighbor list. I got rid of that for loop and replaced it with searching for the right port. Actually, this could go back the way it was because that wasn't the issue. And in fact, I don't even want to call this my end list. I want to put this back the way it was. I liked it better that way. Okay. So we did that. Testing neighbor. We don't need that log actually. But I'll just leave it commented because it was useful. It was really useful actually. Yeah, rename stuff for clarity. The rename and the argument reordering. Now here, yeah, this is still a renaming. Reordering, just a log statement. More log statements. Actually, we can leave that, it's fine. Dump nets, just add some smarts per number of junctions. Use that new, so really the fix, in the end, the fix was just in that special case where we do a DFS on just the junction by itself without the net connected to it first, was to just come at it from the right direction. It was just to fix the neighbor list on the initial call to DFS if there was a junction involved. I think that's the only fix here. Everything else is just cosmetic. Oh, and the port numbers. All right. Fix very subtle bug. Well, I don't need to say that. Fix postcon violation for self-connected junctions. Fix postmodern violin. I know. Anyway, what was it that I actually wanted to work on when I got distracted by this? I think I was working on saving and loading. So this pretty much works, I think. Pretty sure. Right? If I draw some stuff. I think that works. There might still be a couple of bugs here and there. So now what I really want is what is the memory map there? Okay, so first of all, okay, let's just go in here and say load. I have a function which is going to be function save design, and why not? Let's put in a file name. And we will do, first of all, draw grid of everything, right? Which is going to be 0, 0, 120. Am I even using this? Oh yeah, 0, 0, 128 by 64. C store. How does C store work? Dest address. I think it's, I'll do this off memory, but I'll check it in a second. Source address. Length. I think it's also 2000. File name. F name. And then here we will do load design. These are slow, but I don't care. C or reload, I guess. Now we will do, I think we can just call init, actually, if we're smart. So if I go in here and go up into init, we can reset grid, nets, gates, junctions. That's pretty much it, right? I mean, sure, we can gen t info, who cares? So yeah, we will call init. Now we will do scan tiles 0, 0, 127, 63. Right? What are the arguments here? Oh yeah, I don't need this anymore. I'm done with that. In fact, I can just do scan tiles down here because the defaults are what I want. And well, yeah, that's more or less it. Oh yeah, I need to check the addresses. That's right, I knew I was forgetting something. What are the addresses here? Where's the ROM layout? I can never find it in this manual. Oh, here we go. Okay, map starts at 0x2000. Oh, I see, I see. 0x1000 is the extra map. 1000, 1000, a length of 2000, or well, 200 in hex. Yeah. Yeah, okay. May as well do that here. Yeah, let's just try it out. So, menu item 3, save, design, function. Menu item 4, load saved, define. That's probably too long. Disk, save to disk, load from disk. I have no idea what that will do if there's no existing saved design, but whatever, I don't really care. This is load design. I think that's all there is to it. It would be nice also if we had menu item. How many menu items can you have? 5. Reset. Well, actually, no. There's already a reset in the menu, so I don't need to add that. Content. Index local O. Oh. Yeah. This thing. Although, come to think of it, that is draw grid. Oh yeah, I see. Yeah. Okay. So let's just do like a little, you know, like do that. Save to disk. Okay. Let's reset. Load from disk. Oh no! Oh yeah, that's right. I got rid of that argument. Hey, why did I get rid of that argument? I need this for pasting, don't I? If non-zero OXOY to paste at different position. Yeah, I need this for pasting. I don't know why I ever took that out. Ha! Yes! We did it! We have saving and loading. It probably doesn't work in all cases, but you know. Now this actually, I think it's saved to the map, like the cartridge's map, because I gave it a nil file name. Yeah. That is awesome. Wow, unbelievable. Yeah, so let's, oh, I should have, well, we can do a force push, why not? Where are my notes? We did it. Saving and loading, done. IO components is half done. Yeah, that's all done. Copy and paste is next. We could probably do that right now pretty easily. Well, all of the hard stuff is done. The only stuff that's left is actually adding a nice way to do it in the UI. You need a way to select the stuff you want to copy. And then you need a way to select where you want to paste it. I mean, it's already getting a little clumsy with 4 tools that you cycle through. The wire, component, erase, and interact. It's already clumsier than I'd like. The undo mode is like a little iffy being a separate thing, but it's okay. The speed is fine if a little, like, it's a little hard to understand because it's like turning the speed up makes it slower, so people are going to be a little confused, but it's not that hard to get used to. Okay, what if we do copy and paste as a separate mode that you enable from the menu? I don't really like that. I can't decide how to add it into the UI. Well, let's have a little fun. Let's draw some kind of circuit and then save it, because now we can do that. What would be an interesting circuit that I haven't already done? Maybe like an LFSR would be cool. I mean, it would be cool to draw like a whole CPU. It should be doable. There is a lot of space. Definitely wouldn't be easy. Not something I would just sit down and do right now. Why don't we redraw that adder we had earlier? So, actually, let's first make our pulse generator that we had before. So how did this work? I wanted to check if it was not equal to its previous. So I need an XOR between these two, an XNOR actually. I think like this would work. Okay, I just don't want the NOT gate at the end of here. Yeah. All right. Now let's draw our input registers. And just for convenience, so I don't have to reset them all the time, I'll do that. I'm a little too brain dead to remember how I did that adder. I remember I needed to have 3 AND gates for the pairs, and I made some XOR gates. That's something else we can do, which is a little bit simpler. We can just do the XOR. Let's just do the XOR. XOR is simple enough. So it would be nice to have a built-in XOR gate. It's on my list. It'd be nice to have built-in mux gates, actually. Like I say, it's on my list. One, two, three, 4, 5, 6, 7, 8. Whoops. Uh-oh. Good. Now, to properly pipeline this, no, it is properly pipelined. So actually all I need to do is so I just need to delay this by 2 cycles, which I'll draw in a more suggestive way, like so. So now I can XOR anything I want. So let's XOR 2B and not 2B. That is FF. All right, so now if we hit this guy 8 times, 1, 2, 3, 4, 5, 6, 7, 8, we have our 2B back the way it was. We have our not 2B down here. We have FF over there. So now we've answered the age-old question, to be or not to be. So save, and then just for kicks, let's go look at it in here in the map. Our circuit is right there. We just drew it. Yeah. So yeah, there you go. Okay, that will do for now. Whoops. So we still need copy and paste. I want to finish music for it. I may or may not stick with Cirrus. I've been having a lot of trouble transcribing that. Maybe one of my friends can help. So, and then it would be nice if there was some kind of like challenge mode as opposed to you just like making up your own ideas for stuff to do. Like you'd be like, hey, make a circuit that I don't know, you know, like make an arbiter, for example, or make a FIFO, or you know, make a CPU. Like it'd be nice if there was some kind of built-in challenge. You know, making a CPU is not hard. Well, generally speaking, like if I was just sitting down writing Verilog, or if I was even drawing something in that Logisim thing, that like not this Logisim. I called it Logisim, but like there's a piece of software called Logisim, which is one of the best pieces of software I've ever used. It's actually really easy to make a CPU if you don't care about performance. like don't worry about pipelining instructions. Like just have like a little state machine that runs through the fetch, decode, execute, whatever. It just runs through them all one at a time for each instruction. We don't care about pipelining. Oh, and by the way, we don't actually care. Well, in Logisim, you don't have to care about timing. But in here, you do. In Logisim, the combinational gates have a functionally, like they have 0 delay. But here, my gates have 1 cycle of delay, so it's actually a little bit harder to draw a CPU in here, which I like, actually. It's also harder because you can't have multi-bit buses. That actually is kind of an issue. It's still doable if you make like a 4-bit CPU. Anyway, it would be neat. We're getting close to the finish line, actually. I mean, when I first started this, I thought I would never finish, but yeah, okay, I'm stopping this here.